I wanted to go over another improper fraction example with you. We did one on the notes on Friday, but I thought it would be beneficial for you to see another problem set up as an improper fraction. The partial fraction book review does have a few problems in it that contain improper fractions. So again, I thought it would be good for you to go through another problem just to see how that improper fraction example works. So if you look at the problem I have written here, we have x cubed plus 2x squared minus x plus 1, and then we're dividing that by x squared plus 3x minus 4. This is an improper fraction because the power on the top is bigger than the power on the bottom. So anytime that happens when it's in a fraction, we consider it improper. Just like with numbers, if I had 10 fourths is an improper fraction. We could write that as a mixed number. So essentially, that's what we're going to try and do. We're going to see if we can take this fraction and get it into proper form, pulling out a piece of the fraction. And to do that, we are going to use long division. So we are trying to break down the numerator. That's the part that is larger than the denominator that makes it improper. And we are breaking that down using the x squared plus 3x minus 4 from the denominator. So this long division we learned way back in October, and I probably said then that it was one of the things that I liked to do in pre-calculus, and that it definitely comes back a couple of different times throughout the year, and this is definitely a time where it's coming back for us, so we're going to use it again. We have an x squared, we need to make it x cubed, so we need an x multiplied by an x to get it into x cubed. So that gives us x cubed 3x minus 4. And then remember, you're subtracting all of that. That's the tricky part to think about. So we are subtracting the x cubed. We're now subtracting the 3x, but we're adding the 4x. Sorry, I didn't carry my powers through there. I've got to make sure I get that. So 3x squared and 4x. So when we subtract, the x cubes go away. We end up with negative x squared plus 3x, and then bringing down the 1. So again, we ask ourselves, so we have an x squared. We need to make it a negative x squared, so we need a minus 1. So that gives us negative x squared minus 3x, and then plus 4. Remember, this is all getting subtracted. So this is a plus, this one is a plus, and that's a minus. So we end up with 6x minus 3. So the x minus 1 is the part that we factored out. We're going to place that in our answer. Don't forget about that part. The remainder is what's left. So we are left with 6x minus 3 over x squared plus 3x minus 4. Now it's a proper fraction, so the power on the top is less than the power on the bottom. So we're going to do the next step, which would be to do the decomposition part. So we're going to try and break this down. In order to do that, we take the denominator and factor it. So a minus 1 and a plus 4. Those two pieces become our two partial fractions. So a minus 1 and a plus 4. They are both linear, so A and B. And then we're multiplying by the least common denominator. So I need the first one to have the x plus 4, and the second one to have the x minus 1. So the denominator is gone because we multiplied all of this by the least common denominator. So we have the 6x minus 3 on the left, and then on the right we have the ax plus 4a plus bx minus b. So our fraction part is gone. Now we're trying to figure out what the a and the b values represent. Those are the constant terms on the top. So looking at the terms that have the x, we have an a plus b. And then the other two terms, 4a minus b. Those guys are grouped together as well because they're just numbers. They don't have that x variable in common, but they are both just numerical values, constants. So we're taking the 6 and setting it equal to a plus b. The negative 3, setting that equal to 4a minus b. So again, grouping the terms that are the same. The 6x goes with the x. The negative 3 goes with the terms that are just constants, that 4a minus b. This works out really nice using a little bit of a elimination here. We end up with 3 equaling 5a, so a is 3/5. Oh, got an evil fraction. That's all right, we can still work with fractions. So we have a being 3/5 plus b is supposed to equal 6. Well, if I place 6 over 5, 6 over 5 is really 30/5. And if we subtract 3/5, we get 27/5. So the solving part was really easy. I mean, we just had to use basic elimination. The b was already a plus and a minus. But then we ended up with those wonderful fractions in the end. So we have to kind of pull all this information together. We had an improper fraction. The power on the top was bigger than the power on the bottom. So our original fraction is now equal to x minus 1. That's the part that we factored out to make it proper. In addition to that, we have this 3/5, and that represents a. Instead of placing the 3/5 on the top right here, instead of placing 3/5 there, if I place that 3/5 there, then I have a fraction on the top of an already fraction. So we don't really write it like that. Instead, we're going to write the 3 in the numerator and the 5 in the denominator, because it is a fraction itself. So the numerator is the 3, the denominator is the 5, and that went with x minus 1, so it's still going to go with x minus 1. And then the b we found to be 27/5. Again, the top is 27, the bottom is 5, and that 5 is with x plus 4. So this would be our partial fraction decomposition equal to the original improper fraction. So now we have those three terms, three parts of the fraction, and we found the a and the b, and then we used the long division to divide out that x minus 1. So there will be another Zoom session tomorrow. There'll be two set up at 9 and 1. The problems in the book for the review, again, a few of them contain improper fractions so that you can kind of practice another improper fraction problem. And then the other problems are just partial fraction decomposition. The answers to those are posted on Google Classroom. Any questions that you have, please bring to the Zoom session tomorrow, and then there will be a quiz on partial fractions. Have a great day. If you need anything, please send me an email.